Welcome everybody to Automation Developer Days. My name is Niklas Wägert and I will be your host today. I can't believe it's been 6 years now since we started this, and we have been doing a number of events with you guys in the community. You may have noticed that we have changed the name slightly. I promise you we'll get back to that very soon. So what's special with this event? It's hybrid. What comes to mind when you hear the word hybrid? For example, jungle is the mix of house and reggae music, and mule is a horse and donkey cross. Most people think about cars that runs on electricity and gasoline as hybrid. Our definition is that we mix in-person event components with remote event components. Ideally, we want people across the globe to be able to decide if they want to come to Stockholm to engage with peers or if they want to join remotely. We still want to give the same event experience. We know it's hard, and so therefore we have to treat the different components a little bit different. So the 2-day virtual events are shorter, the shorter segments, shorter days. We do 2 days instead of 3. In Stockholm, in the live event, we record everything, so you don't miss anything, except from meeting your peers, of course. I also want to mention the hybrid workshops. This is a great opportunity for you to collaborate. We invite remote attendees to collaborate with in-person attendees. So what can you expect from the day? Well, on the agenda today, we have sessions ranging from everything from container network function orchestration to technical deep dives into NSO to how you can leverage more values out of the robot test framework. But most of all, I'm proud to have the CX team with us today to talk about sustainability. Sustainability is such an important topic that will not go away, and we will keep adding it to our agenda. Later today, we have workshops on this topic. It's a brainstorming session about this, and I'm so excited to hear the readout later on this. Before we go green, I'd like to welcome Kevin Vollenweber. Kevin is the VP GM for the Routing Automation Group, and I'm sure he will give you some more of the clues to why we have made the name change. So with that, I'm happy to hand over you to Kevin.
Thanks, Nicholas, and welcome everybody to our hybrid automation developer days. We really do appreciate everyone taking the time out of their busy schedules to spend the next few days with us. I've actually been a part of this now for 2 years, and it's kind of fun to see as the world sort of returns back to some semblance of normalcy post-COVID. We're really starting to see a renewed interest on focus and investment in tools and technologies that enable our customers to really simplify not only their networks themselves, but the operations of those networks. About 16 months ago, so right before the previous developer days that I was a participant in, we actually merged our routing and our automation teams together. And the merger of those portfolios was really meant to simplify the set of tools and technologies that our customers were going to use to enable them to get to this sort of what I call future state of network operations. Automation is a critical enabler, not just for our customers, but for Cisco. And it's really a big part of that vision of how we see routing and infrastructure being deployed over the next few years. We're even starting to see some of our customers make purchasing decisions around their network technology and their architectures based on their ability to simplify and automate that network infrastructure. This is really where these multi-vendor tools, like what we've been delivering for years now with NSO, become the backbone of that strategy for automation. Customers continue to look for ways they can leverage tools like NSO across the broader part of their network infrastructure. So these developer days really did start with a focus around NSO and building an active developer community. And we think that active developer community is a critical component to maintaining not only the tools that we have, but continuing to evolve the tools towards what our customers need. And so although we've expanded from just NSO to things like our crosswork automation suite, NSO actually remains the backbone or the platform of choice for many of our customers as they roll these networks out. But with the addition of that suite of crosswork products, everywhere from our crosswork network controller to our hierarchical controller, we allow more and more customers to be able to take these technologies and deploy them in their networks. And then with that, we've even simplified the commercial offer. So we've taken what was a bunch of disparate parts that all had their own licensing and terms and built them into a common offer to allow customers to consume more and more of these technologies and consume across the entire portfolio in a much simpler way without the complexities of those different licensing structures and terms across the different components. And so I just wanted to kind of close with a view of our high level automation strategy and vision. You'll hear much more about these as we get into the different technology components throughout the week. But really, when I net it out, it comes down to three simple things that our customers want to see in the network. They want to have visibility. They want to be able to visualize what's happening in the network infrastructure and very quickly and easily pinpoint what's happening either in an outage or a bad customer experience. How do they very quickly understand what's happening in the network itself? They want to be able to provide insights. So we're gathering tons of data with new modern things like streaming telemetry. There's so much data coming out of the network. We have to be able to correlate that data and very quickly provide insights back to the customer as to what's actually happening within the network infrastructure itself. And then lastly, actions. We want to be able to take that visibility, take the insights that we're able to derive, and then push back actions into the network infrastructure like we've been doing for years with NSO. So hopefully you get a lot out of this week. We're really looking forward to this week with you. Thanks again for being part of this and really being part of this active developer community. We look forward to the next few days. I wanted to say thank you again from me and from my teams directly. And then with that, I'll hand it back to Nicholas to kick off the rest of the week. Thanks.
Kevin, that was a great introduction. That certainly helped us understand why automation is so important to Cisco. And it certainly explains why we broadened the event scope and changed the name. So, a reminder to everyone going forward, please challenge our expert team and ask questions on the QA chat. Answer to poll questions as well, because your feedback is important to us and we want to know what you think. So our next speakers are Soumaya Dubey and Koen Bastiaans. Both represent the CX organization. Koen is VP of CX in North, and Soumaya is a customer success specialist specialized on automation. And this session is about what you can do to your network to make it more sustainable using automation. So please take it away from here.
Welcome to our session, Sustainability Networking with Automation. Or we could have called it Application of Sustainability, Energy and Efficiency Principles into Networking by using automation. A full mouthful. I'm Koen Bastiaans and I'm joined today by Soumaya Dubey. And we're going to talk about a topic which I call like very close to my heart, married with a topic which is very close to my passion in engineering. But usually when you hear presentations about automation, either infrastructure or software automation, you will hear business cases about operational efficiency, speed of agility, rollout, security, all of those elements. Actually, today we talk about probably a topic that is way more important, where ICT infrastructure automation meets sustainability, where we use the automation layer to drive energy efficiency in our platforms. And you first might think like, is this not something for like equipment manufacturers or DC designers? No, we will show you today that actually through automation and definitely the link to resource orchestration, we can make a big impact on this topic. And as it's such an important topic, as such an important challenge, with this session, we would like to challenge the automation developer community to contribute to help us in this green and blue challenge by driving innovation into this one. The urgency now of taking actions on climate change has become top of mind. Many organizations and also our companies here have taken sustainability as their top priorities, have taken aggressive goals on driving reduction in greenhouse gas emission. And as the quote here on the slide shows, sustainability is now a business imperative. But let's look at what we can influence as an automation community. Depending on the source, we know that the total technology industry is more or less responsible for 2 to 4% of the global emissions. And 1 to 1.4% is related to everything about data transmission. Another 1% to 1.4%, really the same, related to data center, depending whether you add crypto mining into it as well. We also know that for a typical service provider, the energy part, the energy consumption part of the equipment is the biggest chunk of it, up to 80% of this one. Not only that, we also know that digital solutions have the ability to reduce roughly 15% of the current emissions today. So we're not talking here about reducing energy consumption in our networking, but we also talk about how automation solutions can help drive the acceleration of digitization in other sectors, like retail, like cars, like transportation, and as such contribute a lot more than just in this space. So let's look what Cisco does. Cisco has included sustainability in everything it does. It's part of the core of the culture. Not only that, we have announced publicly our commitment. Cisco will be net zero across scope 1 and scope 2 by 2025. More important for this is actually we have committed ourselves to be net zero by 2040. And that's an aggressive target for an equipment manufacturer like us, because scope 3 contains also the energy consumption of our equipment. But let's look at a few areas. For instance, we are focusing on ensuring that the electricity we use in our offices, in everything else, comes from a green source. We're well on our way of achieving our goals. And we've implemented circular economy principles to everything what we do, by ensuring we recycle our equipment, by ensuring we have programs to refresh in this one. But let's look a bit about scope 3, which also includes the energy consumption of our equipment. We have launched new products, for instance, based on Silicon One, a new router which is 96% more efficient and has an increased bandwidth throughput of more than 35%. What we also do is we want to engage all our employees into this challenge. And we recently launched the Green and Blue Innovation Challenge. By using brains of all our people, innovation and creativity, bringing up new cases, bringing up new solutions, we help on tackling this problem. And one of those members of the winning teams is actually Soumya Dubey. And we will hear more of that of her on what she has done in this challenge. But before going there, let me show a simple quote. One thing our parents have learned us very early, if you switch off a resource that you don't use, you actually save electricity. And it's a simple principle. Of course, it's a lot more complex to apply, but you can easily imagine switching off network capacity, equipment that is not used. This is already applied today, for instance, by reducing fan speeds in data center or by switching off ports. By applying this to the automation layer, we can do a lot more. Obviously, we need to ensure that our networks are still high availability, so it requires a lot more sophisticated than this one. And therefore, I'm happy to hand it over to Soumya.
I love the analogy you shared. This is very interesting. In fact, when we started brainstorming about this challenge, a lot of ideas came in a space where we understood that automation could be an enabler. Before I deep dive into the solutions and the challenge, that how we worked on the challenge, I would like to highlight on the ideas and how it really came about. So the whole objective is, say, for example, we have a network and we want to come to a solution which is more energy efficient. So let's take this example. We scan through the network and there is an analysis report which says there are unused ports that are detected. Now we have a recommendation based on certain logic and intelligence, which says that we can switch off certain interfaces on and off, using the same analogy, in fact, that you were referring to. And after that, there is another recommendation, because we give a list of recommendations, which says that we can apply traffic policy to prioritize certain lanes, so that we choose a route which minimizes the energy usage and also maximizes the bandwidth efficiency. And we can take these recommendations and apply it to our devices directly. So we can apply it to a device or a device list. And this all can happen via automation. And what's the impact like? It has a direct impact towards energy consumption. We're using lower electricity, which also means we're saving dollars, and the carbon footprint is reduced as well. With this, I want to introduce you to the project we've been working on. We call it the Sustainability Insights, aka SUSI. It came out as a part of Cisco's innovative initiatives. And there I actually got to work with some amazing people who've been doing a lot of research in this space, in sustainability, networking, and automation. I'll give you a sneak peek of the technical journey we've had there with an example. But before we go, I also want to highlight the fact that what Poon was as well referring, right? That this topic is quite challenging. It's not that straightforward. There are a lot of things that we need to consider. And our goal is to ensure that we don't compromise with any aspect with respect to standards, rather aim to improve the overall efficiency of the infrastructure and reduce the power consumption. So we started off first with understanding that what is the sort of data that we need to collect. So we categorized the data into three forms. First was the dynamic telemetry data, second static data, and third solution impact. Now the first data, which is dynamic data, is all the data that keeps changing, right? Like say, for example, your CPU conditions, your fan speed, which impacts the temperature, your current that is taken at that point. And then second is the static data, which is given by the manufacturer itself. How is it managed? How is the waste management done, and so on. And third is the solution itself. So this could be varying from solution to solution. And then we take all of this data and push it to SUSI. Now the middle box, if you see, that's the green SUSI box, and the magic happens here. The result of this is, number one, it gives a sustainability score. Second, it gives a recommendation. Now, with sustainability score, it is a score both on the device level and also on the infrastructure level. It ranges from 0 to 1, where 1 is the best score. Second is recommendations. Now, recommendation as well is on the device level and as an overall solution level. We take these recommendations, which are, by the way, actionable suggestions, which can be implemented directly. Now, this can also be done using automation. Now, this is a sneak peek of the slides that we did with Sustainability Insights. And this is a small POC that we've been working on, which is on the ASR 1K device. Now, how SUSI works, it works as a plug and play model. You can take the analytics and insight and plug it in any visualization tool or a model, right? Using APIs and so on. And I'll give a basic example just to give a reference. So say, for example, we have this infrastructure. Just to simplify it, let's take an example of how SUSI reports a particular device. Now, this is an ASR 1K sort of network. And what we're doing here is we're doing an analysis report of one single device. Now, in the report, if you see, we have three major areas. Number one is the SUSI score. Number two is the recommendation itself, which can be applied. And number three is the recommendation priority. Is it urgent? Is it highly recommended? Is it okay? Can we defer it to a later time? So if you see in this particular case, there are two recommendations. Number one, which says that we can consolidate similar devices to a higher version of ASR 1K. And second is that we can configure the fan speed to a different, to say 60%, right? So that the temperature is reduced, which directly impacts also the power consumption. We take all of this data and we configure our devices. Now we could do this using NSO, CNC, and think of how are the different ways that we can really use it in the best way to configure the devices. Now let's look also at the impact that it causes, right? So on the left-hand side, we have the device analysis report before, and on the right-hand side, we have the analysis report after the recommendations are implemented. So now if you see the SUSE score has increased to 0.96%, or sorry, 0.96 to be precise. And then we have the power consumption, which is reduced by 92%. And it has a direct impact on the CO2 emission, which is also deducted by 87%. Now, these were the environmental stats. But if you see that how it has impacted the solution itself, you'll see that now we're using more efficient devices, which are upgraded and are more efficient in terms of how they work, but also more efficient in terms of how sustainable they are, because they are compliant with the circular economic needs, which means they are RRR compliant, reuse, repair, assembly, and so on. And the second is the business part. Now, since it directly impacts the electricity, we could calculate, depending on the region, obviously, that it directly impacts the dollars that are being saved as well. So this is the quick example that I had for us with respect to SUSE. But I also want to give a summary of this closed loop high-level architecture. So if you look at the architecture, we see the first part, which is the infrastructure or the solution. Now, our aim is to make the whole solution more efficient, considering both the aspects, the whole solution and the sustainability. So the first logical step is we collect data. We collect dynamic data, static data. You could come up with more ideas and how we can collect the most relevant data. Then we measure that data, and then we have an analysis report. Now, that analysis report goes to a prediction model, which is also backed up with a learner agent, because we are taking into consideration some best practices and also what we've learned from our previous cycles and so on. And then that recommendation or the actionable items are sent for implementation to our automation suite. And the cycle goes on repeating. So frankly, what is also happening is that we've done multiple iterations in POC, and there are a lot of lessons learned, but there's a lot of work in this area that needs to be done. And we are still working on this challenge because this challenge is real and it needs to be solved. So I encourage all of you to brainstorm on this as well and come up with innovative solutions for your network, because this topic is certainly a topic that needs collaborative effort. Thank you. With this, I would like to hand over back to Poon.
Thank you, Soumya. Very inspirational. And by the way, congratulations on winning the Green and Blue Innovation Challenge with SUSE. I trust that it sparked a lot of creativity, a lot of interest, because this challenge is so fundamental to us that we really need your collective brain power, your collective inspiration, your collective software capability driving this one. So please interact with us, share your use cases, and definitely join us for the Sustainability Network with Automation workshop afterwards. We definitely need your help here. We definitely need your help for the green and blue transitions. Thanks a lot for joining us on this session.
Well, thank you, Soumya, and thank you, Koen. It was great to hear about the green initiatives. I can't wait to see the outcome of the workshop that we will have in the afternoon. Our next speaker is Roque Gagliano. Roque is a technical solutions architect in the EMER region. He will share some experiences on container network function orchestration, and he has some best practices that he'd like to share. So with that, the stage is yours, Roque.
So hello and thank you. I'm happy to present today how we're going to be orchestrating container network functions with Cisco NSO. We all know applications are evolving, so we move in different directions, not just the development process, moving from waterfall to DevOps, the application architecture, moving from monolithic applications to multi-service applications, the deployment and packaging of these applications, very importantly for the topic of today, moving from physical servers to virtual to containers, and finally, the application infrastructure, moving from only being able to host in the data center to a more hybrid environment where we can decide if those applications will be hosted on-prem or will be hosted in the public cloud. So all of these transitions are, of course, influencing container and network functions. In particularly, we've seen that in the last couple of years, we've been transitioned from physical network functions to virtual network functions. So the next transition will be from virtual network functions towards container network functions. Now, if our experience from physical to virtual serve in this environment, we know that that transition was not just a one-on-one. We know that it was not just taking whatever software was running in the physical box and move them to the virtual machine. It had also some transformation where we moved to, for example, distributing that load in many different virtual machines. And we think, of course, that transition is also going to be very important with containers. So it's not going to be just moving virtual machines into a different packaging environment. It will come together with new technologies, but also new operational practices for you and your operational team. So we also know from our experience that BNFs were not all available at once, were not all available at the same time, and it took time to actually have the certifications of those BNF in time to put them in production. So just like we had a hybrid world between PNF and BNF, we are going to be a hybrid world when we move to CNF. CNF will be coming online over time and will be certified all the time. So we need to get ready for this very hybrid environment of the combination of PNF, BNF, and CNF. We also know that from a deployment perspective, we have been implementing BNFs in either virtualization environment, bare metal environment, and as we move to CNFs, we're going to see more and more either, again, an environments where we are either in bare metal or building containers over virtual machines. And finally, but not least, the implementation of public cloud, either as an infrastructure or as a platform. One of the key points is that many times the customer, yourself, do not have control on what is the right development environment, because we depend a lot on CNF, BNF, PNF certifications and what are the right set of technology that are needed to run a specific application. So our orchestration solution has to be adapted to all of these variants. Now, when we look at the CNF on themselves, we see that there's also today a very wide variety on what we are on what do we need to manage. We see that some CNF are simple with a single pod, but some of them are pretty complex and they're pretty much running every expected Kubernetes features. We also see that some CNF do require dedicated Kubernetes controllers, particularly to manage their deployment, and life cycle. In particular, one of the key points is the networking, the CNI, but also, last but not least, we care about the service that are actually carried by the CNF. We know that from a pure cloud native perspective, the containers are meant to be immutable, but in reality, many of the CNF exposes an API and are expected to receive day 2 configurations either through this API or via an element manager. So that, of course, complexifies the end-to-end service on what is needed to create that service. Now, when we look at the Cisco strategy towards CNF orchestration, I think it's an interesting point to take a step back and look at what we've done for NFVO and where we are basically and where we're going, the lesson learned we're going to take to actually move forward towards container management. So one of the key points about NFVO and BNFM and what Cisco strategy has been is that we had tons of success stories. And one of the interesting things about the success stories we have is the variety of the use cases. We have customer running NFVO and BNFM in business service, in packet core, in Open RAN, in IT environment, et cetera, and et cetera. So that diversity tells us a lot about the openness and the flexibility of our platform. The second key success story has been our interoperability. So we are definitely standard supporting different of these ETSI standard has been created by the industry. We were very successful on the different plaque tests. And pretty much many times we were the only available commercial solution for many of these standards. Now, also we believe NFVO has been very successful regarding incubating technologies for the rest of the NSO ecosystem. So a number of NSO technologies came out of what was needed to orchestrate virtual machines. In particularly, let's look at the NSO Resource Manager or the Kicker Plan or Nano Services. So all in all, great done by the NFVO and the NFM, but also just keep in mind in that hybrid world, they're not going everywhere. We're still going to need them. And particularly, if you look at the lesson learned and what was truly amazing about what we achieved with them, we need to think about that flexibility, that idea of having truly general solutions that can adapt to this different environment and different use cases. But the other point is the integration with the overall ecosystem for an end-to-end service. So it's not just about instantiation the VNF, it was also about being able to program those VNF, being able to interact with the data center interconnects, interacting with the end-to-end system to create these very complex use cases. So taking those lessons, we look at CNF, and we look at it pretty much as a continuation of what we've done with NFVO. And we also have the same sort of goals, correct? So we're going to keep doing what NSO do best. We're going to expand NSO to resource lifecycle management of CNF. So that's about instantiating the CNF, being able to scale, being able to turn down a given CNF. And to do that, we're going to be tied to adopt more of the cloud native foundation standards. So in particular, we are going to be adopting Helm as the packet management solution. And we're going to be focusing on Kubernetes as the one integration platform for container management. That's mainly because we see that as pretty much the de facto standard in the industry, but we are going to be flexible to add new platforms as needed in the future. The second point is that we need to facilitate the insertion of the CNF on the end-to-end service. So on one side, we're going to be able to use NSO Nets to program either the CNF or EMSs that deal with the CNF, but also reuse all the great NSO features like Resource Manager, like Kicker, Plan, being able to do recovery, being able to create service automation, check syncs, etc. And with that, we believe we can create an abstraction where basically a service or a use case is implemented maybe today in VNF and facilitate that migration in that hybrid environment where maybe part of the service is done in VNF, part of it in CNF, and tomorrow moving to full CNFs. Now, one of the points we won't be doing is implementing lifecycle management of the cluster infrastructure. We believe that typically the cluster of your choice will have either tools by itself or an ecosystem of tools that will allow you to deal with that lifecycle in a much better way. So these three use cases, we see in the recent weeks that the Linux Foundation has basically announced a new project called Nephew, and that also mentioned these three use cases. And we believe that that's a validation of our strategy, where NSO will basically take care of use cases number 2 and 3. One of the key points is that implementation may change, and you will see that we will still rely heavily on Yang as our data modeling solution of choice. So one key point about Helm, we have decided to take this as our the key packet management solution that we'll be relying on. One of the key points for us, it's about adoption. If you want, one of the points when we were looking at ETSI standards was that the adoption by the VNF vendors of the packaging solution from ETSI and allowing the onboarding of VNF in a pretty much zero-touch way was not something that was really achieved. It was impossible mainly to go to a VNF vendor and get standard-based packages. And that was something that we always needed to do on-prem with the customers and would take a lot of time. In the CNF world, what we see is that most of the vendors are adopting Helm, and Helm becomes with a definition of basically all the Kubernetes resources that are needed to instantiate this CNF. So by adopting Helm, we are also adding a lot of flexibility on what is needed to instantiate a given CNF on a given environment. And also, of course, we are able to leverage Helm's release number and versioning, and that allows us to basically allow customers to create use cases such as CNF upgrades and lifecycle management. Now, what is our solution? So our solution will have two main components, one of them residing in NSO, and then another one residing in the Kubernetes cluster as an agent. So let's start with NSO. So in NSO, we're going to be implementing a CNFO package that will be released by Cisco starting in May 2022. And this CNFO package is a new package that will expose these CNF definitions, Node one, to either be used by external systems via our APIs, RESTconf, NetConf, JSON RPC, or by other NSO services to create a more complex end-to-end view of the service. Now, the second component, it's the CNFM agent. So the agent in itself, it's going to be residing particularly on Kubernetes, and it will be taking care of the communication either to Kubernetes API using the native REST API from Kubernetes, or with Helm using also the Helm API. So by separating this the problem in two, it allows us to isolate NSO from the specific API implementation of one specific solution, like Kubernetes in this case. It also isolates NSO from the chattiness of the web API or the notifications that are actually received from the Kubernetes cluster, and keep it NSO focuses on the thing that matters to him. Now, the integration between NSO and the CNFM will be via NetConf, using NetConf API, both from programming and for notifications. So from an NSO perspective, we're going to have every CNFM looking like a NetConf device, and of course, the CNFO package using that device to create more this CNF view of the world. Now, what can you do with a given CNF? So for a CNF that it's present, we'll have, first of all, you need to onboard its chart, so its definition via Helm. And what you're going to do, of course, is to install, to upgrade, to list the available CNF. You're also going to be able to watch basically whatever is happening in a given pod, service, or deployment, or a replica set. So you can create even more complex logic, again, using Kicker, using all the well-known NSO features. Now, one of the interesting things is that if needed, if the CNF exposes an API, you can actually automatically create a CNF device inside NSO and allows you to program that device using the NSO nets. The other point is that if you need to program the CNF via an EMS, you can also use the NSO nets towards that EMS. So a very complete set of use cases will be possible using this implementation. Now, one of the questions that you may have is, what about this CNFM? It is not similar to the VNFM because it doesn't need to implement all the functions that we were doing in a VNFM, because Kubernetes does a lot by itself. So everything regarding scaling or health checks, that is now delegated to Kubernetes. So what it is pretty much an API agent towards the cluster. Now, when we decide on where do we host, we see two options. One is to have one CNFM hosted with every single cluster. And the second option is having a CNFM which is outside of the cluster and looking at more than one cluster. Today, the first option we are supporting is one CNFM per cluster. We think right now, after talking with several customers, is the right solution that allows us to deal with not just with manageability, but also with high availability and security aspects. But we are open to support the second solution in the future. Now, taking these new assets, we can definitely combine them with existing assets to create that end-to-end view. So as we said, in that hybrid world, we're going to have PNF, BNF, CNF that needs to be programmed via the net or via an EMS. We're still going to have to instantiate and lifecycle management some of these BNF through the VNFM and the NVO. And of course, we need to deal with the data center SDN layer, either Cisco or third party. What we are adding is the option to also lifecycle management our CNFs. And by the addition of, on one side, the CNFM, the CNF manager that is hosted in Kubernetes, the CNFM net, which is a netconf net, and the CNFO core function pack. All of all, giving you APIs to create this end-to-end service that will give you very complex use cases in this hybrid environment, but also an API that may be abstract of the specific implementation, where something that today leverage a VNF, tomorrow can be migrated to leverage a CNF. So all in all, as a conclusion, we are expanding our Mano orchestration to CNFs, but particularly also hybrid environment. We are adopting Kubernetes and Helm, particularly because of the market traction, and also Helms in terms of what CNF vendors are actually testing and certifying themselves, but we are open to other platforms. A CNFM will act as a netconf agent towards the cluster, and as we saw, we are going to be in the first stage hosting those agents inside the cluster as a specific pod deployment. So all the NSO features that we've seen, all of those great features are going to be available towards those CNF. So we can use the net, we can use the kickers, the plans, the nano service to allow you to create those end-to-end orchestration logics. So with that, we are finished on the presentation. We're probably happy to take some questions from the audience. Thank you.
Thank you, Roque. That was an interesting presentation. It was also good to hear about the new add in the core function pack. So I wonder what Kubernetes platform will support in the future. Moving on to the next session, we have a session from our engineering team, Troy Ryang and Christian Reneskog. They will talk about the new NSO concurrency model that we have launched in the NSO 6.0 release. This is a really interesting presentation, and I look forward to this. All right, stage is yours.
Thank you, Niklas. My name is Troy Ryang, and I'm here with my colleague Christian Reneskog to introduce the new concurrency model for NSO 6.0 for you. So there is a long-running effort to make the throughput of NSO better than it has been before, and we will go through what has been done. First of all, some terminology. It's important to distinguish between response time and transaction throughput, where response time is an individual user's request and the time for that request to really be responded. The transaction throughput, on the other hand, is the amount of requests that the server can handle at a certain point in time. So it is a big difference, and it's also common that with less response time, you can gain throughput, so you have to be aware of that. Concurrency control, then, that is the way that the server handles parallel transactions. So it can be in several different ways, often referred to either pessimistic or optimistic concurrency control, and using locks or not. One important thing then when you're running parallel transactions is that there will be conflict. They need to be detected and they need to be resolved. And this can be handled in different ways. Also, transaction isolation is important. So when you are running a transaction in parallel with others, how are your transaction impacted by the others? Are you reading commits that are happening in the fly? Or are you looking at something that was in a point of time when you started your transaction? So first of all, some background on our NSO server. This is how we present NSO normally. This is a very old picture, but it doesn't matter because the important thing here is that we always mention the service manager where FastMap resides and the device manager which handle all the devices, the two-phase commit to the NEDs or the devices themselves. And then we have the CDB, which is the data storage. It is often a misconception that CDB is a database management system. It is a persistent data storage. So there is a transaction manager separate from CDB that isn't always depicted. And this is where most of the functionality for NSO is. For instance, FastMap and other stuff. So a white box view of NSO would rather be a transaction engine or a transaction manager, which is the yellow part here. And from that, the service manager and the device manager inherits its capabilities for FastMap, for two-phase committing and all of that. And also the data that is handled is stored in CDB. So currently, the transaction manager is one with a concurrency control mechanism that is one big lock for all functionality that is needed to be guarded from concurrent behavior. That makes it often a part of a contention. So when the NSO demand for more throughput grows, this becomes a problem. And a picture that shows it this much better is this, which shows the complete life cycle of a transaction with a read-write work phase that is outside of this gray box. The gray box denotes the global lock that is necessary for storing a transaction. And during that part, no other transaction can be committed. It has to wait. The read-write phase that is outside of the lock, that can run for minutes or hours, or we don't know. And during that time, the writes that is done in this transaction is stored. And then we enter the lock, and we have an initial part, which is the validation of the writes that was done in the work phase. And then we have the service create invocations, and all other validations are next. And then there might be kicker evaluations, customer callbacks, and also a CDB subscribers that the customer use to identify changes in transactions. All these are marked red here because it is the user that controls how costly this will be in performance. For instance, in validation, there are young expressions like must or when or all of these. And in the service invocation, it's the code itself. In kicker evaluation, it's XPath expressions. And CDB subscribers can also be more or less costly. So introducing the customer or the programmer inside the critical section makes it very hard for us to control the throughput. So therefore, we need for scaling to change this. And this is what we have done in 6.0. We have actually moved out a major part of these costly, customer-friendly changes that the customer wants to do. So the critical section decreases. So the work phase is as before with the read writes, but we are now collecting the reads that are done in the transaction. And the validation as well as the create invocation are run outside of the critical section. So they are done in jeopardy. So when we enter the critical section, we need to check if the reads that we have done matches what is in the database, so that there is no conflict that we didn't know of. If it's okay, we can go through with the parts that are inside the critical section. And you can see that the kicker evaluations, we haven't moved them out yet. There is still stuff to come in later releases. But we also expect users not to use CDB subscribers anymore because kickers are more efficient. And we also expect users to use the commit queue if they want maximal throughput. So the conflict detection is that the checking that we do is that the read set of my transaction doesn't have conflicts with writes that has been done by other transactions since I started that I didn't know of. If that is the case, my transaction needs to abort. So that is a very big programming paradigm shift that I need to be aware that my commit can say that it's conflicting and you need to do it again or resolve it some other way. The important part here is that services are under our control. The FastMap algorithm is under control and they can be restarted. So there is a great work done for handling restarting of services that conflicts automatically without any user intervention. And also, if the conflicts are often happening for a certain service type, it implies that this service type isn't very well defined, so it needs to stop running parallel. It needs to do the default to the old behavior where it's single streamed, and that can also be done automatically. So in a bit more detail, this is showing what's happening. In the outer rim, we have transactions. These guys are all transactions, but this is the work phase where transactions read stuff and write stuff, and this can go on for minutes or hours. At some point, the transaction is committed, and then it goes through this boundary into the service phase, where validations and service invocations are done, still in parallel. And at that point, more read set and more write sets are collected, the parts that relate to service invocations or validations. And then when this is done, and one at a time, it enters the critical section for applying. And this is where the read set is verified against the write sets of earlier transactions that has committed since we started this transaction. And if the reads from the service part of validations conflict, this aborts but restarts inside this boundary. So this is something that just resolves itself. But if it's a read from the working phase, it needs to abort. Okay, thank you. And over to you.
Yes, so changing the concurrency control has given us some obstacles and opportunities. So let's talk about these. Changing the core architecture definitely comes with unexpected risks. There's a lot of less optimal design choices taken in the past that you will have to fix. And fixing 4 out of 5 of these doesn't mean that you necessarily will gain anything. So this has been a long journey to get where we want to be. But changing the core architecture also comes with unexpected gains. Opportunities will present themselves when scrutinizing the details of the system. So let's talk about a few of the opportunities we had. Here are some functional highlights for NSO 6.0. Lockless dry run. This is one of the most important mechanisms to verify that the transaction does what the user intends. And there's a lot of customers that use this feature in an automated fashion. Previously, this was done inside of the critical section since the service and validation had to be invoked there. But since these are now moved outside, we can also move dry run. And by making dry run lockless, we can reduce the overall time spent in the critical section, as well as making response times faster. There's no need anymore to wait for transactions to perform a dry run. Parallel execution of commit queue items with NSO nodes. This is a key feature to give throughput in a clustered environment. The collected read set is now used to detect read-write conflicts on queue items ahead. If there are no conflicts, the queue items can be run concurrently towards NSO nodes. And if there are conflicts, queue items will continue to be paced as they have previously been done. Improved device locking. Since service invocation was previously done within the critical section, we couldn't determine what devices was part of the final change set. If the device lock couldn't be acquired right away, the transaction would have to be aborted. Device locks are now taken automatically before entering the critical section. We can now wait until these becomes available to us. This will simplify both user code and operations. So by running more parts outside of the critical section, we can now also start thinking of trading response time against other benefits without affecting throughput. By enabling compression on service reverse diff, we trade response time against reduced memory growth and smaller CDB. And thanks to the changes we had to make for 6.0, we've also been given opportunities to improve the system on previous versions. So let's mention a few of these highlights that we already released. By changing the internal service metadata handling, we've been able to improve the commit queue error recovery for RFM services. We've also done internal performance improvements for CDB, making internal data structures becoming more efficient and providing an overall performance improvement in the system. We also made kicker evaluation more performant, reducing the time spent inside of the critical section. So let's talk about some numbers, what we have achieved in terms of throughput by making these changes. But first, some expectations. By making these changes, we expect better CPU utilization, making use of all the cores. We also expect improved throughput, more transactions pushed through the system within any given time. In terms of functional expectations, we expect minimal or zero code change to get the benefit. We expect no impact on CDB. We don't want an expensive migration experience for our customers. We also expect minimal API changes, and we expect most of the user code running outside of the critical section. Now to some actual numbers.
Yes, so how do we verify that you have the minimal API changes or no API changes, and that the impact of migration is low or none? You use real-life use cases, and this is what we have done, and we present some of these here. And we are always running on a rather large machine, either 72 or 96 cores, and with 1.5 terabyte of RAM. This is not because NSO 6.0 requires that, but we want to have no dependencies on the machine's behavior, and we want to run bare metal and have sort of infinite amount of resources to verify NSO. So this first use case is an LSA cluster with one CFS node and two RFS nodes. Only one is presented here with the measurements, but that is because these two are the ones that are pacing this use case. And as you can see in the RFS node, which is running NFVO, you get a more than threefold increase in performance, or the throughput. So it uses more CPU in a shorter time and converges everything. You can see that it's still on the CFS node runs for a long time. This is because this use case has a conflict internally with itself when it runs in parallel. And that is sort of a deficiency of the use case itself. And what this algorithm does is that it detects that this is the case, and the solution to this is to start to run this service type in sequence instead, so that these conflicts doesn't just require more and more restarts. Anyhow, we can see that the CFS node do improve in wall clock anyhow. And the memory utilization is reduced to half or less than that. Next use case is a single node with stacked nano services that runs the TSDN function pack. And this one also has a wall clock improvement of 2 or 2.5 times. And it uses more or less the same amount of memory, a little bit less, but it runs on with much more CPU utilization than before. And the last one is a LSA cluster with 2 nodes, one CFS node and one RFS node. And these are just simple services that runs very fast. But the thing is that the LSA commit queue improvements for 6.0 greatly reduces the time to at least 3 times faster than before. So with this, we can conclude, and we can also propose to look at the presentations of our colleagues, Claes Nesten and Victoria Furdas, which will have a technical deep dive in the programming paradigms and how they affect you as a user or a programmer. And with that, we thank you.
Thank you, Tri and Christian. I know that was a challenge for you to squeeze all that information into 20 minutes. I know you are looking forward to the deep dive in the in-person event in Stockholm. So next up is Ulrik Stridsman. Ulrik is a software engineer that works with the CTO team. He will talk about the HA functionality in NSO and how HA has evolved from 5.4 up till today. So take it away from here, Ulrik.
Thank you, Niklas. Here and welcome to this presentation that I will give to give you an overview of the high availability feature in NSO. First, I will just give you a brief history about the HA in NSO. It has been provided by a package called TailF HCC. It was released during the NSO 3.x series of version. It is just short for high availability cluster communications. Simplistic framework that does the simplistic part, doing failover, doing replication, handling virtual IP. It also has a possibility to advertise VIP over BDP by using Quagga and the Quagga NAG that we have, and by using device templates. The feature we have now, or what we focus on we have replication to 1 or 2 secondary nodes. We support synchronous or asynchronous replication. We support automatic or manual failover. We support virtual IP. And we can advertise VIP over BGP. And to notify northbound systems, we also create alarms on state changes. Starting with NSO 5.4, we did the big change of moving the HA framework into NSO, making it the first-class citizen of the software. We had a lot of improvements in the startup behavior. We added auto-recovery features. We re-implemented virtual IP. And we re-implemented the support to advertise VIP over BGP. Instead of using Quagga, we use GoBGP to get the more simplistic approach. In NSO 5.7, we added a rule-based consensus algorithm to avoid split brain. We added a high availability monitor in the web UI. And now in the latest release, we added a package upgrade feature. I will go through all the features. First, starting with the built-in features of the framework. Now you don't need any additional package for using HA. It does the same thing as before. It handles the replication, it handles the failover, it creates alarms to notify northbound systems. You still need to enable HA in the NSO's COM file. And if you want to use virtual IP and BGP, you need to use the 5.x versions of the HCC package. One big change is the YANG model. We did this change to be backwards compatible. The top container used to be named HA that contains the configuration with all its cluster members. The new container is instead named high availability, but contains the same configuration, but with a slightly different terminology. The startup behavior has improved a lot. Enable is now persistent. The startup behavior is controlled. We also have added features to make the system to reconnect it startup. And that is what is part of the auto recovery features, where you want to actually minimize the hands-on work when there is failover or there is a restart of the system. And this setting has also improved the prevention of split brain, as when starting up the system or in case of a failover, when you enable HA, it will look at its members. If there is a primary available, it will connect to it instead of causing a split brain scenario. And then in NSO 5.7, to further improve the prevention of split brain, we added a rule-based consensus algorithm. And by using this, split brain is much less likely to occur, and we support it through a 2 or 3 node setup. And I will go through some scenarios to show you how it works. Let's first show how it used to work when we have no auto recover features enabled, or you're using the old TLF ACC package. We have a system with replication. There is a network disturbance. The primary node, of course, detects that its secondary is missing, but it will continue in primary mode, so there will be no downtime. The secondary node will detect that the replication is broken, so it will step down to state none. And after the reconnect timeout has expired, it would step up as primary. And this is what the definition is. It's what is split brain, because we have 2 running systems and we can't tell which one is the active one, since we have 2. And that's why we added the rule-based consensus algorithm. And now we'll go through how it works in a 2-node setup. We have a system, a cluster with replication. There is a network disturbance. The primary nodes will now, instead of continue being primary, it will step down into state none. The failover node will step up into state none as it lost its primary node. But then after the reconnect timeout has expired, it will step up as primary. And now we don't have any split brain scenario. And the use case for using this is a setup where you, if there is a failure and you don't want to, and when replication is broken, you don't want it to be in service anymore. But this might not be a scenario that is accepted by most customers. And to complement the 2-node setup, you can run this as 3-node setup. I will start again. And to complement the 2-node setup, you can run this with a 3-node setup. And when the network connection is broken between the primary and its secondary nodes, all nodes will step down into state none as the connection between the primary and the secondary is broken. And then after a while, when the reconnect timeout has expired, the failover secondary will step up as primary, but with the difference that it will be in state read-only. And it does this by telling the northbound system that I might soon be available for service. And then after a while, the secondary will probe its cluster members, and when it finds that the primary is available, it will connect to it. And this is, of course, detected by the primary, and it will step up into read-write mode to restore redundancy and be in service for northbound transactions. And then we have this second scenario of a 3-node setup. When the network connection is broken between the primary and the secondary, the primary node will still be in primary state and in read-write mode, so there will be no stop in serviceability from the northbound system. The secondary node will still be connected to its primary, so there will be no disturbance in redundancy. The secondary will, of course, step down into state none as it loses connection with its primary. But then after a while, it will continue to probe its cluster members, and when it finds the primary, it will reconnect to it and restoring full redundancy. Then I will go through some web UI features that were added. In NSO 5.7, we added a high availability monitor. It gives you a single view where you can see how the nodes are configured and which state they are currently in. And you can also see if there is a node that is not available. And now, in the latest version of NSO 5.8, we added a package upgrade feature with the purpose of simplifying package upgrade in an HA cluster to actually minimize downtime. So here you have a single view. You can upload packages to your NSO system, and by a single click you can distribute the packages to all the nodes in the cluster and doing a package upgrade, and this to minimize downtime. We have a lot of requests over time about features that we have not been able to add into the core of NSO, so we have provided them as additional packages. Currently, I would say we have 2 such packages, and they have targeting to actually supporting for those who are using a load balancer in front of NSO. One is HA Portier, a simplistic port forwarding application in front of the primary node to tell the load balancer that when this port is enabled, then I'm available for service. And if you use a load balancer in a different setup, we have an HA status package to provide authentication-less status of the system. And this is to minimize the maintenance when username and password changes. And they are provided as is, so there's no support for them. And we hope that we will be able to put this into the NSO in the future. Thank you for listening to this presentation, and over to you, Niklas.
Thank you, Ulrich. That was a good presentation. Now, I'd like to move on to the last presentation and welcome Scott Barwick from Datadactus. Datadactus is a systems integrator and a provider of network automation solutions based on NSO. We have a long history with Datadactus that goes back to the time before TailF was acquired by Cisco. Today, Scott will talk about the robot test framework and the added value that you can get from that framework to more than just for testing. So with that introduction, welcome, Scott. The stage is yours.
Thanks, Nicholas. Hi, everyone. My name is Scott Barwick, and I'm CTO North America for Datadactus. And the title of my presentation today is Use a Robot for Network Automation. And the subtitle perhaps might be a little bit more insightful, a little bit more specific, which is getting more value from your NSO test automation. And you'll see the tie in just a few minutes. But first, a bit about Datadactus. We are a network automation consultancy with a long history of working with the BU and the NSO community. We've done more than 75 NSO projects and have more than 300 employees working in offices around the world. And we're very excited to be here today. I'm virtual, and I wish I was in Stockholm, but that'll be next year. All right, so for today's presentation, it's all about the context of NSO projects and automation. First of all, it's the motivation for automated testing. And with that, the core is getting more value by reusing your automated test framework to accomplish network automation tasks. For those who saw the word robot and showed up to hear about robotic process automation, that can be a topic for a future session. All right, so we'll start with a poll and to see what test automation frameworks might be in common use out in the field. And so while you're doing that, I'll just talk about the ones I've listed. The robot test framework, that is currently my favorite. It has a lot of value in terms of the higher level presentation of what they call keywords, and then a core of Python, which is really good. The PyTest, of course, JUnit, very common out there. And then Selenium is a way that people automate their UIs, and that works with either robot or JUnit and certainly others. And then, of course, Lux. We've all used Lux for NSO projects. Okay, so why test automation for NSO projects? First, I'm going to come over here and go to my terminal and show you a successful test run. This test run is one of those that we run on the Datadactus core robot test framework, and you can see it runs a number of tests, and they've all passed. And what I'll tell you, in fact, there's some PyTest up there, so we use both. What I can tell you is that if you look at my command, which hopefully you can see, this is run against NSO 5.1 functionality. And that'll be significant in just a minute. So basically, here's a set of tests it runs. It verifies the functionality of what I had going in an NSO 5.1 set of features. What I'm going to start running is I'm going to run the same tests against NSO 5.4 functionality. And for those who know what happened between 5.1 and 5.4, that we'll see that in just a second. So that is running, and I'll come back to this. So why test automation for NSO projects? Well, NSO automation is software, and it's well established that finding a bug early in software is a lot cheaper than finding it later. And certainly you want to find it before you hit release, before you hit production or the customer networks. And the earlier you find it in conception, of course, in design and all that, it's a lot easier. And so test automation helps you do that. And but that's about bugs. What we also want to consider, and it's very, very important, is that it's not just about bugs. It's also about changes in functionality. Whether you knew you were changing functionality or not, you need to find a way to verify that the behavior you expect is still the same behavior that will go out to that next level or that next stage of deployment, whether it's development, testing, or release. And so now I will come over here, back to my terminal, and see that we had a failure. Remember, again, I ran it first against 5.1. I ran it this time against 5.4. And if I were live, I would say, who knows what changed, what big thing changed between NSO 5.1 and NSO 5.4? And so let's find out. I scroll up here and I find the failed tests. And these tests weren't specifically testing for that, but what they did was they exercised the REST connection. And if I look, I can see a 404, and clearly then we all know that in 5.3, REST was officially taken out and no longer could be used. It was deprecated before. Cisco gave us plenty of advance notice, and so it's not a problem there. But it is a problem if you didn't notice that and you just went to 5.4 and you checked your connections, you checked your services and said, oh, through the CLI and said, oh, all my services are working, so that's great. And now you deploy it and all of your northbound interfaces failed because you were using REST. So it's very clear that it's not just about bugs. Those changes in functionality need to be caught too, and that's exactly what test automation can do for you. And then the way I like to see is continuous testing for continuous information. It's continuous information about how your system, your automation system is going to behave. And so with these automated tests, you can test them in your development environment and move those over to your test environment, and you're still running the same test or a subset or maybe some more even. Moving to staging for acceptance testing, and then even in production, the continuous monitoring is something that can be done with your automated test framework, and that's really where we're going. So we've established that automated testing is good. So now how do we use it for more than just testing? Well, we'll start with an example. Verifying the HA status. This is something that I've done a few times in NSO projects, and here is an example. It's a little bit of a streamlined example for demonstration, but it's largely functional, and it shows you that you can have, and this is, of course, the robot framework, you can have these high-level commands that say verify the HA status. Here it's an LSA environment, and it breaks down to the RFS and the CFS, and you can execute against that. You can verify the HA, you can call those to the verify HA in the default state, and that's another keyword, encapsulates some more functionality, breaks it down a little bit, and then you verify each individual node status. And you'll notice here I'm trying to use the better words for some of the components in there, and we'll be going with those. So with this verifying the HA status, let's take a look at the key infrastructure bits that you've had to build into your test framework, or you'd have to have available in your test framework just to make your tests work. Well, the first one is this, we call it send to, and this is basically a way to send a command to something. Send it to what? Send it to a variable. This happens to be the variable NSO. Remember, this is a keyword. This is a function, a method in some sense, where we've encapsulated and we passed in the NSO name to address mapping as a parameter. And then, of course, you need be able to send a command in. So you have this basic functionality already to send to any device that you have in your inventory that you built the connector for and send it a command. You also can tell it what type of interface you want to use. In this case, it's a CLI. You can recognize the CLI command, and but you could have a REST prior to 5.3, or you could maybe netconf and even bash or some proprietary REST based thing to say OpenStack. And then here's, in this particular example, you show that it shows that you can do more than just a single device. You can, here, there's an active NSO, and this one's changing to send a similar command to the backup NSO. Okay, so that's the key infrastructure that you've already built just to do your tests. So how do we reuse that test infrastructure for automation? If I had another chance to do an interactive poll, I would say, what is the thing that you like doing the least with NSO manually? And I put up there update software, update packages, reload packages, things like that. But the one that I would vote for is resetting the HA state on a number of nodes. To go out to the command to these different devices when power has failed on one, or it's crashed, or you've upgraded it, is really something I don't like to do manually. I did it a few times manually, and then I wrote this test, or this robot encapsulation of functionality. So this is really a test an automation enabled by the test framework. And so for those who don't know, I'll just quickly show you what you have to do just to take an HA node that, after it has failed over to the backup, back to the active, to your default state. You have to send a command to override the current slave to the active. Then you have to go and activate that on the NSO. And then you need a way to make sure that the sync has completed, because it's got to sync its database. And at least as far as I know, that isn't exposed in the CLI. So you have to go to the logs and make sure you see that in the logs saying, yeah, sync is complete. And then you go over and then you roll revert on both the active and then the backup. And so, or the backup then the active. So you have to do all those commands just to get your HA back into its default state. So I wrote something to do it for me. And then what we show at the bottom is that here's where we actually reuse that exact command that you've written for your test automation. And there you can verify that it all worked correctly. So that's how you do one. That's how I jumped in and I did one just to make my life a little bit easier with the core bits of the test framework. So how can we do even more? Well, in order to answer that question, I said, well, what are the components of a test automation implementation that I might reuse? I've mentioned them along the way, but let me list them here. It's the multiple device access. I built ways to connect iOS, iOS XR, Juniper, NSO, even OpenStack with the RESTconf, and these different interfaces. I built those already. Device inventory, I know what my test devices are. I probably have that in some sort of JSON file or some way to easily add to it. Obviously, configuration loads with either large templates or individual parameters. I need that because that's really what you do a lot of testing for. NSO access for the show, config, request, all those basic commands. You built those for the showing, for doing your testing of your specific NSO commands. Sometimes you'll build in bash SSH access as another device type and another connector. And then of course the XML and JSON data processing. Things coming back from NSO, from devices these days can come back in JSON or XML, and there are a lot of great tools that you can use to process those. And then if you have a UI, like I mentioned Selenium before, you might have built ways to encapsulate various bits of testing a UI that you can then take those and reuse those. So these are the components of a test automation implementation that if I list them down here on the right side, you can see those. You can see these bits. And then on the left side, I said, well, what can you do with these various components if I wanted to do some standard test automation or network automations? And some of the things I mentioned as pain points before that might be in a poll. Device onboarding is one, package upgrade, OS upgrades. Of course, my HA state management is something I would do, but you can also do the health checks. What about the continuous monitoring in a production network? If it's read-only, it's pretty safe, and so you can do health checks just to go out and reach out into your various systems and make sure that things are running okay. But then you can take all these and use them for these other bits, put them together, and see what else you could enable with those with your test framework. So those are the individual components. And then I said, well, okay, well, if we try to put them together, can we really call it a network automation platform? Is that too strong a word? Or is it just a set of scripts that you could run and make your life a little bit easier? I thought maybe we could think about it a little bit bigger than that. And so I listed the types of behaviors that you need in a real network automation platform. And these are just the basics. And so you can see that device connectivity, configuration are in there. Of course, simple automations, but then really complex automations need to be enabled. And then a REST API and results database are core in these kind of test automation platform components. So with those, I said, well, okay, if you have a COTS, a commercial off-the-shelf system that is a workflow platform, you're clearly going to have all these things and no questions. And there's a lot of good products out there for that. If you pick an open source platform, you'll probably have to build your device connectivity and your configuration access and some of those components in the checking yourself, but you'll get the simple and the complex automations and of course the database, the results database and the API. So then if you want to use a test automation framework to do more of these things, clearly you're not competing against a real off-the-shelf platform. And even an open source because of the complex automations. I'm not going to be that aggressive and say that you could do that, but can you do many other things? Perhaps. And the device connectivity and configuration we've already talked about, so you can get those. Simple automations, probably because they're simple, for some definition of simple. But then the REST API and the results database kind of scratched our heads and said, well, yeah, we don't really have that. So then we set out to say, well, what happens if we built that ourselves? You could do it yourself. Can we end up doing that? So we, in fact, built a REST API wrapper for the robot framework to run against NSO implementations. And it has a results database. And I'll show you just a quick demo of that. It's a Flask implementation that calls the Python ability to run a process. And so that's running here, and I will show it with Postman. And of course, I picked my favorite HA to demonstrate that with. And so the first thing you need to do is go out and get what tests do I have available. I have exposed for this demo. We call them collections. I've exposed the verify HA status and the HA activate tests, which are then actions that you can use. And if I want to say, okay, well, the first thing I'm going to do is through my API, I'm going to go verify the detail of the HA verify. And again, I've already run this a few times, but here I hit it. I am in fact hitting the API here. You can see from Flask, from the Flask log, and then if I go and run it, then I have this collection set up, and I'm going to hit send, and it's going to go and it's going to be running. And in order to do that, I'm going to send it again and see if it's still running. It's still running, and because these tests are asynchronous, so we had to have the ability to send a command, put the request for the command in the database, and then be able to poll, because again, REST is asynchronous, as we all know. And so there, in fact, it's done, and I can go look at the results. And it's indexed here by the database index for the simple case. And the test ran, and HA is in the default state on the CFS and RFS. So that was all successful. And now for some future time, when I want to go reset the HA state or go activate it on a set of nodes, I can run this command. That's the detail. It goes out and it gets the doc string. If I need to activate it, I'm going to go run it. This is old. I'm going to run that, and I'm going to go try to see if its status. I've given it the ID, and again, this is all very simple and quick for you, but I'm running, and I'm going to probably be running for a little bit because it's more involved, and eventually this will finish. Now it's done on my simple Docker setup, and I can go check the results. Again, I'm giving it an index, and this has completed successfully. The tests have 0 errors and 0 failures, and it ran in nearly 20 seconds. So that's a case where I have built or I have available to me a REST API and a results database for my test automation framework. So I have many of the capabilities that you need to do a lot more with your test automation framework, to do simple network automations that could save you some time and get a little bit more value out of that test setup. Okay, well, that is all I have for today. In summary, the important thing is that we really feel strongly about test automation for your NSO projects. As I said, NSO automation is software. It's very complex software. And in order to identify changes in behavior, whether they're from bugs or from valid functional changes, that is the real value for test automation. So you know exactly what is going out into production. But with that investment in your test automation, you can leverage that into some other benefits, such as testbed automation is a natural. If you have a complex setup from from development to staging, pre-production perhaps, and then into production, there are a number of servers there, a number of systems, and you could really leverage what you've done to access those and work on the maintenance of those or those tasks that you really just don't like to do by hand. UI automation is also possible. If you built in something with Selenium and you use it to drive test cases, just point it at something else, do a bit of work to drive some of the APIs or the UIs that drive your network. That's all possible. And then, of course, with care, actual use for your network maintenance and audit and monitoring is possible. So that is about it for today. I enjoyed this time, and I look forward to being back in person next year.
Thank you, Scott, and thank you all presenters. And thank you everyone for listening in today and engaging with us. Today you have learned about the Cisco's green initiatives. You have learned about container network function orchestration, and you have learned what we have done under the hood in NSO to get better performance, and how we have improved the HA capabilities to get a more robust system. You also heard about the additional values that you can get from using the robot test framework. Tomorrow, we will focus more on the product suite, crosswork network automation. And if you have signed up to the workshops, I'll see you over there. If not, I hope to see you back tomorrow. But before we close, I'd like to give you a final reminder. Please fill out the survey. We would like to know what you think about what we did and how we can improve. So with that, have a great day and enjoy the workshops if you signed up, or a free afternoon.